All right, so this is the sixth and final module of this workshop. And this workshop or this module will be a little bit shorter. It's only 30 minutes long. And I want to take the opportunity to discuss some case studies. Some of them I showed briefly on that one slide before, but we'll spend a little bit more time on some of these. I will say ahead of time, some of these I have personal involvement in, some I don't. Some have more customer willingness to share, others are less so. So if I seem reticent to provide more information on any particular one, it's either because I don't know or I'm not allowed to say, but I'll let you know that ahead of time. Okay, so the first one that I want to talk about is a rather unusual one, and this one I did have personal involvement in, and that was Shell vessel scheduling. So basically, they had these drilling platforms out in the Gulf of Mexico, starting with Gulf of Mexico anyway, and they had problems delivering to them. You can see, although in some respects the platforms are quite large, in other respects they're quite small considering all of the activities that are going on there and the materials that are coming through. And so all the materials need to be supplied on a just-in-time basis. And they had a situation where they were using pretty much obsolete technology, in many cases even sending faxes back and forth and using whiteboards and magnetic boards in order to schedule vessel movement back and forth. And basically they had a lot of vessels that were pretty much constantly in motion in order to get the waiting, the just-in-time deliveries that they were looking for. Now, you might think, well, why are just-in-time deliveries all that important? Well, if you shut down one of these rigs, keep it from doing what it needs to do. Let's say it needed a delivery of pipe and that delivery of pipe did not arrive in time. They were talking about an average cost of about $1 million per day per rig when they're shut down. Now, that can buy a lot of extra vessels, to make sure that things get there in time. So that was basically the problem. It was a very complex environment. Lots of different things were being delivered, different constraints, different types of problems, the availability of the equipment, the delivery performance to the onshore facilities as well as to the offshore facilities. And the weather obviously caused a huge problem too. So where it might take 12 hours for a large boat to get someplace and maybe 10 hours for a small boat to get to that same place, if the weather kicked up and they had headwinds or large waves, the relationship might get reversed and the small boat might take longer or might not even be able to get there at all if the waves were too big. And so, and it's not just the weather at the port, it's the weather at the port, the weather at the destination, and the weather in between there. So lots of variability in the process, lots of things going on. There we go. And so these are some of the places. So we had ports in Galveston and ports in Foshan, and obviously platforms all over the place that they were shipping to and from there. And again, if I could, maybe Mars needed something and Cougar needed something, and the same ship could potentially do it. Would they send one ship or would they send two? Things like that. And they had initially 62 vessels that were servicing this area. Basically, they set up Simio as the core of all of this. So this was a bit before our digital twin, but in fact, it was kind of an early test of our digital twin architecture, where the Simio vessel scheduling took information about the vessels from other places, took information about their near-term need for what needed to be done and when, what kind of materials would be available, what kind of demand would be available. So these platforms moved frequently, and so they had to plan for how they were being moved. And by the way, you can perhaps tell by the colors that this was actually a slide that came from Shell, illustrating how their architecture of this system worked, with Simio at the center of their architecture. And basically, they were able to dramatically reduce their number of ships that they had by changing their process, by allowing better scheduling, and they were saving, I believe the number was $200 million per year by more efficient scheduling and using their ships and getting rid of ships that they no longer needed. So that was the first success. And again, I'm happy you can interrupt with questions at any time. Not hearing any questions, I'll just continue on. Hey, this was another case study. Many of you have probably heard of John Deere making big tractors and farm equipment of all sizes. They've gotten into the consumer business a little bit, but their main business, I believe, is still these huge tractors that they use on huge farms. And basically, they were planning their foundry operations where they would make the castings for their big engines that drive this equipment. And they were doing it, they had actually used, and this is true of Shell as well, that Shell had used two other scheduling tools prior to this, and both failed. John Deere also had used either one or two scheduling prior to this, and both had failed. And so they had gone back to planning in Excel. And so they basically had one guy supplemented by a team of others who was doing a plan for the week, I think a daily plan with a 1 week horizon for basically all of the various components that went into this. And they had an MES system, but their schedules were disconnected from MES and ERP. So there was a lot of basically poor production performance, poor throughput. Now, this was an interesting study, I think, from a standpoint of information, and this is not illustrative of Deere as much as illustrative of common what people know and think they know and really don't know. So they basically got their experts together with our experts and basically said, hey, if you can model these three constraints, we can generate a good schedule. And so this was a multi-day meeting that they came up with these conclusions. And of course, I'm oversimplifying it here, but they came up with the conclusions of being able to handle priority orders, gantry space, and core availability, we can generate a good schedule. So we created a model that considered all those things and came up with a schedule. And guess what? It was not a good schedule. So then they came back and said, oh, well, we forgot you also needed to model iron flow. If you can model this aspect of iron flow, then we'll have a good schedule. And so we did add iron flow constraint on there, and we still had a bad schedule. So then everybody was scratching their head saying, well, why is it not generating a good schedule? They said, oh, well, because we haven't considered the labor for the core setters. And so we have to sequence the molds in such a way that it will allow the core setter laborers to work, where they need to be at the right time. And you might guess that wasn't enough. Neither was adding pattern groups. And it wasn't until we got the 7th and 8th constraints in that we finally generated good schedules. Now, again, I don't mean this as a criticism in any way of John Deere, but rather people often think they know a lot more than they really know about the process. And, Joe knows one thing and Mary knows another thing and Fred knows something else, but, they don't all get together and talk as much as they need to talk. And so it isn't until that you get a model that represents all of this stuff and brings it all together that the model becomes the knowledge base describing the system. And it's often when they encounter the model, that is often the first time that people ever really understand how their system works. And so, although they thought 3 constraints would solve this thing, it took almost 3 times that number of constraints before we could generate a good schedule. Okay, F-35 Joint Strike Fighter. This was a really interesting one, and I got within distance that I could have actually touched them, but they said if I did, they'd have to kill me. So I didn't touch one, but they are really cool fighter jets. If you ever get a chance to go see one up close, it's very worthwhile. This was done near the beginning of their ramp-up program, where they started off producing 1 a month and they wanted to end up producing 1 a day. Now, that doesn't sound like all that much. You just, crank the dial on the production speed and everything works out, except that there's a lot to it. They often use $1 million fixtures, multiple fixtures that cost more than $1 million each. And often these fixtures have to be requisitioned a year ahead of time. And, it doesn't do too much good to ramp up, your ability to create left wings without ramping up the ability to create tail wings, etc. So, ramping up across the board, ramping up their people, their staffing at the same time, and just adding another crew doesn't double your productivity because that new crew doesn't know what they're doing yet. And so that new crew takes some time to get online. So basically, they were looking to mitigate their risk and their cost by having a model to help them plan how to ramp up. So this wasn't actually doing a detailed design model of the facility. The facility was already well designed, but this was looking at ramping up, how do they coordinate their facilities and how do they schedule their facilities, and not on a day-to-day basis, but on a month-to-month basis over the course of years. So that was a very interesting one. And again, they had very significant improvements to their ramp-up facilitated through their Simio model. Okay, this one is, let's see, so this model has been genericized, and I'm trying to think exactly which model this was. And actually, nothing strikes a bell on me on this one. I apologize. I thought I knew which one they were talking about here, but oh, yes, I know now. Yes, this was a European company, actually, multinational corporation. And basically, they make really big, expensive equipment with long lead times. And the customer test is heavily involved in the testing and final delivery, and involves very heavy penalties if they deliver late or they don't get it tested in time or things like that. And there was a big disconnect between master planning and the detailed production scheduling. So again, Simio provided a digital twin to plan and schedule all the activities for both fixed orders and tenders or orders that would take kind of with some discretion or offers to make something. And basically served as I indicated, that kind of universal translator to synchronize between the various production departments in the engineering and master planning. Okay, this one is another genericized one. A lot of the large companies consider the use of Simio to be a competitive advantage, so they're really reluctant to talk too much about it. So this is one where it's a $10 billion company, lots of plants, products that probably most of you use pretty much every day. And they did a lot of using Excel for tracking and communicating. And they used a lot of tribal knowledge, the 35-year experienced guy to apply rules, constraints, priority, and sequencing. And it was very difficult for them to predict the synchronization delays, and they had lots of unplanned downtime. So again, the solution here was scheduling of all the operational areas with the automatic feasibility checking. And again, a very common problem is that most scheduling tools generate nice looking schedules that are either infeasible to start with or they become infeasible very quickly. And they typically run overnight in order to generate the schedule, and then they're out of date within an hour. Simio, when used in its scheduling mode, generally takes from 2 to 5 minutes to support a typical scheduling horizon. And so you get a schedule that's good. As soon as something happens that would make the schedule bad, you just rerun the schedule, and now you have a good schedule again and automatically deploy that schedule. So that was used in this area to save $20 million annually at just one single plant. And this is one of those ones still in the early phases, but we're hoping that they will take that then and put it in another 50 plants or so. Metal production, yet another customer that doesn't want to let their competition know what they're doing. But this is an aluminum production company, very large, $11 billion company. And again, they were having the same types of problems, lots of manual effort, lots of difficulty coordinating people, and they actually went to where most of our clients want to keep the person in the middle of the process. So Simio generates a schedule, a person looks at it, maybe tweaks it a bit, and then distributes it. In this case, they wanted the Simio to provide a real-time scheduler without a man in the middle. And so it was constantly sensing what was going on. And as things get changed, like let's say a furnace or a pot of metal came out late or was getting cold or something like that, they would automatically report that. Simio would pick that up, generate a new schedule, and deploy the new schedule so that a driver, for example, who was taking something from point A to point B, might be told mid-trip to, nope, belay that order. Instead, take this to point C because it'll be too cold by the time it gets used at point B. So gave increased visibility and synchronization and increased asset utilization and throughput. And let me skip past this one. Denmark capital region, I had some contact with this one. And this was rather interesting. Their hospital system, they had a set of hospitals that all worked together in Denmark and shared lots of things between them. And amongst other things, they had a central location where they had essentially an ASRS system with robotics for dealing with sterilizing and then storing away sterilized surgery equipment. And then when a particular doctor at a particular hospital wanted to perform a particular procedure, he would note that he needed, maybe 5 different surgery packs to support that procedure, and this was generated just in time to his operating room. One of the interesting things about this is that some, not all, but some of these facilities were connected by tunnels, and they had the delivery type of robots. And basically, this kind of worked in the dark. This was another totally automated system where they would just enter what's needed, and Simio would run the schedule and determine what needs to go where at what time, requisition the robot to come to the ASRS, automatically withdraw what it needs from the ASRS, and deliver it via these tunnels to the OR where it was needed. And so all of that was a pretty impressive system and met all of their performance targets. BAE, being a defense contractor, we can't talk a lot about them, but as you can see in the picture there, it's hard to tell, but those gun barrels that are pointed in every direction there, those are probably, I'm guessing, maybe 40 feet long and maybe 18 inches in diameter. And that's what they were producing at this facility. That was one of the things they were producing at this facility. And it turns out they had been using another product, and they called us because that product could not handle some of the labor issues. And they were using it in a design mode, by the way, mostly design, trying to keep up with, from a design perspective, trying to keep up with how would they schedule different things. And so, we said, oh yeah, well, we can easily do, encounter that deficiency you were encountering in the other product. But in addition to that, we can actually use that same model that you want for design and use it for scheduling. And they were, absolutely thrilled that they were able to do that and did that. And at that point, they kind of went quiet. So basically, we helped them with their first model. And then from there on out, we hear almost nothing from what's going on with them, except for the fact that every few months they come in and train a few more people and buy a few more copies of software. So we don't know exactly what they're doing with it, but all I can say is they must consider themselves very successful, if quiet, in doing what they're doing. So that was kind of a little bit of detail into a few, and I think we're running about out of time. But again, this is a slide that I showed you before. Some areas of successes in design, some areas of successes in scheduling. If anybody has any particular question about any of these, I would be happy to do the best I can to answer it, but probably can't say too much more than what's actually on the slide.
Thank you, Dave. Thank you very much for the amazing presentation, folks. Do we have any questions for Dave? Oh, wonderful. So it looks like we have had a very productive presentation today. Thank you, Dave, for your time.
Okay,
we have...
pleased to present. And if anybody has any additional questions, you can feel free to contact me at this contact information. Again, don't forget there's about a 2-week window on that offer for training if anybody is interested in taking the next step and even just learning a little bit more. It's a pretty good deal to do so.
And all the participants, in the pre-workshop presentation, in the pre-workshop instructions, there is a link and details on the discount that Dave is talking about. You could refer to that for further information. Before we call it a day for the boot camp, I would like to thank all the participants and speakers for making this event successful. And further, we would like to thank National Science Foundation for sponsoring this event. As a small, so what we will do is we will try and make all the information accessible to all the participants. That would be the slides and also the recordings once we are done finalizing them for release. However, in the meanwhile, we will very much appreciate if you all could please fill out a post survey that we have just sent out to all your emails, and the link for the post survey is also available in the chat box right now. We would very much appreciate your earliest attention to this, and as soon as we receive responses from all the participants, we'll go ahead and then from the bootcamp team, we'll send all the participants an email with link to access for the recordings and the PowerPoint presentations used over the 2 days. Once again, thank you all for your time over this week, and especially the whole Thursday and today as well. If you guys have any questions, please feel free to stay back. If not, we'll be calling it a day now. I'll be here on the call to stay back and talk to you guys if you are interested. Thank you very much again.